use the joystick as a model.
Do you have to,
There's this thing called the dev ref. Remember the device reference. So we're going to take the output from that servo and connect it to the get angle. And you notice that data type matches. So what are we going to get out of the get angle?
the angle?
Thank you. That's kind of a stupid question, actually. So I'm going to right-click on the output, and I'm going to create an indicator. Okay? So that indicator, if we go to our front panel, we see that it's created an indicator right on our front panel, so that we're going to be able to see a live update of what the angle is. The next thing we want to do is set angle. I'm just going to move that over. So we're going to use the device ref again. So you see how we can chain these functions together by using the device ref in and the device ref out. Let me ask you a question. Review from the first part of the thing. Which of these functions is going to run first?
Get angle?
Why?
Because the wire goes out.
Exactly, because we've set up a data dependency by chaining the device ref together. That's really important, and that's a nice way within LabVIEW to make things happen in a certain order. Okay. And so what do we need on the set angle?
An angle.
Ben, you glazed over one thing and said that the data types match.
Ah,
I don't think you mentioned before what happens if they don't match.
well, let's try it. A good example of something that won't match is connecting our joystick device to our servo device. And we get a broken wire. And if you hover over the wire, it will tell you that you've connected two clusters with different contents. You tried to connect a joystick to a servo. Okay? You're right, I glossed over that. And I think we'll probably, that's as deep as I'll go into that topic. That's a really good point. So what do I need in order to set my angle? On my front panel, I need a control. Yes, thank you. So what I'm going to do is I'm going to create a numeric control, and I'm going to choose a knob type because I think it's kind of pretty. And I'm going to set that to be
0 to 180, it only does a half turn.
Thank you. Set that to be between 0 and 180. So when I created that knob, it created a terminal, and that guy we're going to hook up to the angle input here. Okay. So, yes, question?
Can you go back to the panel?
Yep.
It's not actually 180 degrees, it's more like 70. Is there any way to change that?
Yeah, you can change the range of the knob by just changing these numbers.
No, like to slide it so it actually corresponds to the 180. Oh.
Yeah, you can turn this, and you're going to get a live update as you go. Okay, so did I miss anything? Am I ready to run?
No.
So you can control the set angle from the laptop itself?
You can control the set angle from the laptop itself. Yes, that's a really good point. So in this application, where is the program running? On the C-reel, on the target. But where is our knob?
Computer.
It's on the dashboard, on the laptop. So you can control and view things live in this manner. In competition, you're probably not going to work that way. You're probably going to give it a command to say, go to this angle.
So like on the joystick.
On the joystick, or you'll have a joystick mapped to the servo or something like that. Okay? So what am I missing? Why? Let me try and run. Someone already said, but this is a good opportunity to point something out. If I try and run, we see we got a broken arrow. It's actually going to tell us what the problem is. Servo close required input is not wired. So it's a nice way to tell you what the problem was. You see down here, I've created my servo close, but I didn't hook it up. So where does that have to come from? We just follow the pattern, and we connect that back up there. Okay? So let's go back to the front panel, and I'm going to run it again. Save changes. Okay, so our tank drive is it working?
No.
No.
You on.
Oh,
Is it an
it just started working.
Oh, did it? Okay, that's probably a good point.
Now it's not. Did you press something else?
Yeah, I must have pushed something else.
No,
But what
no. Your battery's almost dead.
Oh,
so
okay.
it's going into
Yeah.
a power save mode.
Okay, good to know. We'll just leave it there for now. We're going to go into the exercise in a second. So, assuming a battery wasn't dead, we'd still be driving, because we haven't changed that part of the code. But now see what's happening? We've got, those of you who are nearby can hear it kind of trying to get there. I'm giving it a command, and you see the readback? It's slowly going to the desired angle. So there, we've added servo control. Okay. Any questions? Yep.
The error in and error out for motor control, what does that actually do?
Excellent question. The question is, what about the error in and error out for motor control? Actually, the error in and error outs are on everything. Well, at least they should be. Well, they're not. But they're in a lot of things. Basically, one of the benefits of using this device ref to chain multiple functions together is it lets you put them in sequence. You can also use the error in and error out to do the same thing. Because whenever you connect the input to the output to the output to the output, then you're creating a data dependency and you can force things to happen in a certain order. That's a secondary benefit. What do you think is the primary benefit of the error signal?
Error handling.
Error handling, right? It will tell you if there is an error. If you have done something wrong, if you have put something into an invalid state, or you've given it an improper input, your error output will tell you that. So in general, good programming practice when you're doing LabVIEW programming to use those error ins and outs, because then you can monitor them and see when something went wrong. Yes, Sean?
You take your error out and put an indicator on the panel to print out error information?
Yes.
And is that just a...
I'll show you what that looks like. That's a really good point. So let me use a couple of these. So let me show you what I'm talking about. Right now, which runs first, the watchdog feed or the servo get angle?
Same time.
Same
time.
They happen at the same time. In other words, we can't tell. Why not?
There's a race condition.
It's not really a race condition. A race condition means there's some potential for something to go wrong. Really, there's no data dependency between them. There's nothing saying go here first or go here first. So they're just going to happen essentially simultaneously. And sometimes that's fine. We don't care whether we read the servo angle before we feed the watchdog or not. Sometimes we do care that certain things happen in the right order. So if we were to chain up all of these error signals, I'll just move this over so it's not obscured. Oops. And we can also create an indicator of the error state. So what does that look like on the front panel? It's a little bundle of information which contains the status. So check mark is good, X is bad, and if there were an error, and I don't think we'll be able to simulate one right now, there would be some sort of number here and some sort of description here that told you what the problem was. And really good LabVIEW programmers, even if they're creating their own sub-VIs, will put error handling in so that when you end up building a program which has hundreds and in a lot of cases thousands of sub-VIs, you don't have to go guessing where the error happened. Okay? So if we were to run this, we wouldn't see any errors, but that's what an error signal looks like.
Yeah. Cool.
1:25, which leaves us about half an hour for a Q&A workshop type of session. Before we kind of call it quits with this part of the presentation, are there any other questions? Yes, sir.
Ben, by wiring the errors, did you just set what would go first and second?
Absolutely.
Yeah. Okay.
Absolutely.
So we can use that to direct our program?
Yes. I just want to maybe take a second and say thanks to everyone for coming out. I've been really impressed, as I mentioned at the beginning of this session. This is my first year being involved in an FRC competition. I'm a long-time LabVIEW user and a long-time LabVIEW instructor and educator. And just what I've seen in this couple hours today, I'm blown away by how quickly you guys can pick this stuff up. Mentors too, but mostly I'm talking to students. Okay? So,
mentors a little bit longer.
Absolutely. So I just want to congratulate everyone for their answers and their participation today. I think this has been a really good session. I'm not going anywhere. I think we're still in the room for at least another half an hour. I'm happy to answer any questions. I mentioned before that, and I gave you a link to my website, which is lvmastery.com/tipjar. Will let you see the videos based on this and the other stuff about the joystick. Please feel free to check that out. Just very quickly want to mention, if you have any mentors, part of your teams, that may be interested in a little bit more LabVIEW training, we can do that as well. And if you wanted to come talk to me about that, I'd be happy to.